Welcome back everyone. So in my last video, I talked about different types of simulation actions and what UVM reporting macros does. So, there are several simulation actions associated to each of the uh, reporting macros. So in this video, we are going to talk about the several ways in which we can use the override methods. So those override methods are similar to what we used back for the severity and the verbosity override videos. So we can just uh, override, replace the simulation action that particular macro performs, and we can adjust it for a certain hierarchy as per the requirement. So let's begin. So I will do this with my same test bench of simple UVM adder. And like always, I will always write all the override methods in my start of simulation phase. So there are mainly two categories. The first one, which you will write on code, and the second one you can write during the runtime. So you can write directly on the command line and you don't have to simulate the code again. So let's begin with the first category, and inside that I have divided the simulation action override into three categories. So the first argument is going to be the severity. So, so the severity you are targeting, whether it is UVM info, it is UVM warning, error, or fatal. And the second argument is the simulation action you want to set. So it is going to be action. So like our uh, other videos in which we did the overrides for verbosity and severity, specifically for verbosity, because in severity overrides we did not have the hierarchical variant, but here we do have hierarchical variants like we had in verbosity. So I will begin with my first method. So it's set report severity action. So as you can see that the first argument should be the severity, and let's say we are targeting UVM info, and the second argument is the action you want to perform. So we could do a lot of cool stuff and some some nonsense stuff also. So what I will do, I will target the driver class. So here we have environment, then inside our environment we have agent, and the instance of the agent is A, as you have watched in my previous video, and then driver. So I will replace all the UVM info, the simulation action of all the UVM info with let's say UVM count, or let's say UVM exit. So as you can remember in my previous video, UVM exit is assigned to UVM fatal and it just terminates the simulation. So right after getting our very first UVM info in our driver component, so here we have our first UVM info mm, right here. So right after getting this, uh, the simulation should terminate. So let's find out. First, I will check the code for one more time, whether I have made any modifications during my last lectures. For example, I will comment this severity override to avoid any confusion. And inside our driver, everything is fine. Let's check our scoreboard. Yep, it is also fine. Weights medium, medium. Everything should print. Let's compile our top level file. Okay, let's run mission. Okay, let's see what is happening right here. See, the simulation just break. It just break in between and it quits. And you can see that only one of the UVM info of driver is accessed and then it just simply quits. So this proves that this just replaced the particular severity, uh, uh, the simulation action of the severity or of the UVM info reporting macros present inside the driver class with UVM exit. And as we have discussed in my last lecture that UVM exit simply quits or terminates the simulation. So let us use the other variant. So the other variant is the hierarchy one. So here you don't need to do any hierarchical reference. You just simply write the same thing and you will just add hierarchy, HIER, at the end. And let's say uh, throughout this entire hierarchy, I want to replace all the UVM info, uh, let's say, or I should say, let's say all the UVM error with UVM display. So if we will get any UVM error throughout our entire simulation and in every component or objects, then this will replace the simulation action of those UVM error with UVM display. So as I can recall that for the UVM error macro, the default simulation actions are combination of two: UVM count, which increments after every UVM error macro is triggered and UVM display. So you are basically turning the UVM error into UVM warning or UVM info because their simulation actions are UVM display. So first we need to trigger the error, and for that I will uh, intentionally I will write the bug in my scoreboard. So here we will always get UVM errors, and instead of getting any count, it should just keep on uh, displaying the errors. And also just to make sure, uh, because we could set the limit of how many numbers of errors you can receive before the simulation terminates. So let's just say uh, in this example we have 10 sequences, so we should receive a total number of 10 errors, and let's just set the max error quit count to 5. So here I have already written it. I will just uncomment it, and just remember you have to declare the instance of a UVM report server, and you have to, using the scope resolution operator, you have to assign the get server method, and then you could do this. And here you can see that I have already set the max quit count to be 5. So since I have intentionally implemented the error, the bug in my scoreboard, so for each of the sequences we should receive an error, and there are total number of 10 sequences, so we should receive 10 errors. But as per the limitations right here, it says that if we receive more than 5 errors, the simulation will terminate. But on the same time, we are replacing the default simulation action associated with UVM error to that of UVM display. So it will not have UVM count, because for it to quit after 5 occurrences, the simulation action should also include UVM count. So let's just save the code and let's just see that whether the simulation terminates after we receive 5 errors or not. Trying to make sure that I have saved every of every SV files, right? And this is the hierarchical variant, so we don't have to reference to a particular component or object. It will get applied the entire UVM test bench. Oh, see, even after receiving 10 errors, the simulation did not quit, and the quit count remains 0 out of 5 times. So this particular message itself proves that the simulation did recognize our set max quit count uh, method which we used. We bounded that after receiving total number of 5 errors, the simulation should quit. It did take that into consideration, but since we replaced the simulation action of UVM error to that of UVM display, the counter did not increment. It did not. So that's how much crazy thing you could do by replacing the simulation action. I mean, some of this stuff does not make any sense, but for some practical examples, it will make sense. And I will show you in my upcoming lectures where I will show you how you could write a log file with your reporting macros.